Okay guys, we're going to start the quadratic formula. Most of you guys have already learned this before, so this should be review for a lot of you guys. So the quadratic formula is going to be, and the quadratic formula is used to solve for the x-intercepts when you cannot factor them. You can also use it when you factor them as well, if they are factorable. So it's negative b plus or minus square root b squared minus 4ac. Everything's inside the square root of there. Everything divided by 2a. Make sure everything is being divided. Okay, you have to memorize this formula. So we're going to be using parts of it to describe what type of answers we're going to have. So we're going to use the stuff inside of the radical, this b squared minus 4ac, and depending if that is positive, equal to 0, or negative, it will tell you what type of solutions you're going to have. We call that the discriminant. So first part here is if your discriminant inside the radical is positive. If it's positive, you're guaranteed to have two real solutions, meaning you're going to have two answers. The parabola is going to touch the x-axis twice. Okay, so what that visually looks like is this, just like that. It's going to touch it twice. Okay, and this is when your b squared minus 4ac is greater than 0. Okay, your next scenario is if it equals 0. If everything inside your radical equals 0, then it's going to touch the x-axis once. It could be going up or it could be going down. It doesn't matter. Okay, that means that the vertex is going to be at the, or going to touch the x-axis. Okay, and then our last scenario here is if it's negative. So if the stuff inside of your radical, your discriminant, is negative, that means that your parabola will not touch the x-axis at all. Okay, it doesn't have to be in those quadrants, it could be in any quadrant, but it's not going to touch them at all. Okay, we also call that two imaginary solutions as well, which we kind of learned about imaginary numbers already. We're going to be talking about that again today. So in example 1 here, I'm going to do example 1a, and then I'm going to want you guys to pause to do example 1b. And we're going to do this about 3 times. So please pause it when I ask you to, and do the problem when it's necessary. So in example 1 here, we're just going to use the discriminant to describe what type of answers it's going to have. So it's either going to have 2 real solutions, 2 answers, 1 answer, or no solutions, or you can call it also 2 imaginary solutions. It's the same thing. So first thing we're going to do here is identify our A, B, and C, right? There's always a 1 here. So let's identify our A, B, and C. So this is my A. A is 1. B is 6. C is 8. And we're going to use that formula, b squared minus 4ac, right? And depending if that's positive, equal to 0, or negative, we're going to have a particular type of answer. So let's just go ahead and plug in our numbers, okay? And you have to use orders of operations here. So let's plug in our b. So we have 6 squared minus 4 times 1 times 8. Okay, orders of operations. You have to use PAMDAS. If you don't follow PAMDAS right now, you're going to get this wrong. So there's no parentheses. I mean, there are, but there's nothing to do in them, so we can go ahead and cross that out. Next thing is exponent. 6 squared is 36. If you go 6 minus 4 first, you're going to get this wrong. Okay, then it goes negative 4 times 1 times 8. All right, exponent is done. All right, if right now you subtract 36 minus 4, which I know a lot of you guys are itching to do, you're going to get this wrong. Okay, subtraction is the very last thing here. You have to multiply. Okay, so that means you got to multiply all 3 of these guys. So it's 36, and then it goes negative 4 times 1 times 8. So that's pretty much negative 32, right? So multiplication we did, no division, no addition. Now we have subtraction. In this order, you must do it, or you're going to get it wrong. So 36 minus 32, that is just 4. 4 is definitely greater than 0. That means we're going to have 2 solutions, 2 real solutions, okay? And you can even solve this if you wanted to. I mean, take a look at this. This is going to be factorable. If we wanted to factor this guy, we can definitely do it. 2 numbers and multiply into 8, add up to 6. Hopefully, you guys are good at your factoring now. Positive 4 and positive 2, right? And if we wanted to solve for these x's, what x's can we put in that will make that equal to 0? Negative 4. That guy is negative 2. So I'm not asking you to solve for the solutions right now. I'm just asking you to describe what type of solutions are we going to have. Are we going to have 2, or are we going to have 1, or are we going to have none? Okay. At this moment, I want you guys to pause the video, and do B. I'll give you guys a few seconds here to pause, and then I'm going to continue doing the problem. All right, let's do this problem together. Hopefully you guys did it. So identify our A, B, and C again. So here's my A, here's my B, here's my C. We use the same formula here. So this is 6 squared minus 4 times 1 times 10. Okay. Orders of operations, parentheses, nothing to do. Exponent I have, 36 minus 4. You really don't have to write that 1 anymore. Okay. All right. Do not subtract. That is the very last step here. So we go ahead and we multiply. 36 minus 40. 36 minus 40, this is negative 4. Negative 4 is less than 0. So that means it is this guy right here. No real solution. Or you can say 2 imaginary solutions. That doesn't matter. Okay. So we just go ahead and write no solution if you want. Or 2 imaginary solutions. You can abbreviate all this stuff. Okay. That means that this does not touch the x-axis whatsoever. You can graph in your calculator and you can see as well that it's not going to touch the x-axis. Okay. In example 1a, it definitely touches the x-axis. It's going to touch it at -4 and -2. Okay. All right. Let's move down to example 2 here, and I have the quadratic formula written out for you again. Okay. Like I said, you got to memorize this. Now we're actually going to use the quadratic formula to solve for x. So earlier we just described what type of answers. Now we are actually going to solve for x. Okay, you want to use a quadratic formula when it's not factorable. Okay, you could use it for when it is factorable, and you're going to get a nice number. But when it's not factorable, you got to use brute force, and we're going to use quadratic formula. So example 2a, we're going to use a quadratic formula right now, and we're going to first identify our a, b, and c. So this is my a, this is my b, this is my c. My A is a 3, my B is a -5, my C is a -2. And let's plug everything in. Okay. Remember, this is to solve for x. And we're going to have 2 answers. Because we got a plus or minus here, that means that there's 2 answers. Okay. Alright, let's plug everything in. Make sure you plug everything correctly. Okay. So we have -5. I'm not skipping any steps here. Plus or minus square root -5 squared minus 4 times 3 times -2. Everything is being divided. Okay, make sure everything is being divided, because I see students do this and you're gonna get this wrong. If you do it like this, you're definitely gonna get this wrong. Okay, everything's got to be divided. So 2 times 3. All right, we're not gonna skip any steps. We're gonna use PAMDAS still. Okay, it's helpful to write this down vertically. I used to teach this to my freshmen. So there's no parentheses. There's nothing we have to do in the parentheses, okay? All right. I want to let you guys know that the most important thing in this problem is this right here, the stuff inside of the radical. If you get the stuff inside of the radical incorrect, meaning you don't simplify the stuff inside the radical correct, you are going to get this problem wrong. That is the very first thing I look at when I grade this. I'm looking to see that the stuff inside the radical is simplified correctly. All right, let's go ahead and start doing this. So we can go ahead and do this negative part for the 5. So this would be +5. Okay, plus or minus. And we can even do the 2 times 3 in the bottom, which is 6. All right. The main thing here, like I said, is still the stuff inside the radical. Also, don't get cancel happy here. If we have a 5 up top and a 5 down below somehow, please don't cancel them out. Okay, you can't do that. If you cancel anything in the very beginning of the problem, you're probably going to get this wrong. So don't do that. Alright, so the stuff inside the radical, like I said. -5 squared, that's my exponent, okay? Get that out of the way, so that's 25. And then we have -4 times 3 times -2. Then we got to multiply. You subtract in this radical, you're going to get it wrong. You're going to see I'm going to rewrite this 5 outside and this 6 in the denominator a couple times here. So we have 5 plus or minus square root 25. And, you know, you can use your calculators for this stuff. -4 times 3 times -2. I'm just going to punch this in my calculator. It's not a big deal. Okay, I'm not trying to impress anyone. I just want to make sure I get this correct. So this plus 24. Make sure everything is being divided by 6. you forget to extend that division bar, you're going to get this wrong. All right, we're going to keep on going. So this is 5 plus or minus square root of 49 over 6. 49 is a perfect square number. This is a good number for us, okay? So when your number is a perfect square inside your radical, that actually means that the actual problem is factorable, okay? If it's a perfect square like this. So we're going to keep on going a little bit, and this is going to be 5 plus or minus 7 over 6. All right, you need two solutions here. You're going to get two solutions. If your radical disappears like it did right now, because the square root of 49 is 7, you're going to get two solutions. You can't stop here. You have to keep on going. Okay, so our first solution is 5 plus 7 over 6. That's one of our solutions, right? And then we're going to do a 5 minus 7 over 6. Hopefully you guys can see that we separated a positive and a negative, okay? Then you just have to do this out. So 5 plus 7 is 12 over 6, and our first solution is 2. That means that this parabola will touch the x-axis at 2. Then we do the next one. 5 minus 7 divided by 6, and so 5 minus 7, negative 2 divided by 6. This reduces to negative 1/3. So at negative 0.33333 repeating, it's going to touch the x-axis, okay? So like I said, when your radical is a perfect square like this, and this is the number I'm looking for when I'm grading your exams. If it's a perfect square, you have to write out two answers. That means that it's also factorable. I mean, I'm pretty sure you can see here, we could have broke this bad boy up into, I'll write it over here. This could be 2 parentheses, and this would be, according to my solutions that I have, right, negative 1 over 3. So this would be 3x, let me move up a little bit, 3x plus 1, and then x minus 2. Right? How do I know that? Because I'm working a little bit backwards here. I said each parentheses equal to 0, and I can say what numbers would I put in. Like in here, I would put negative 1 over 3, subtract 1 divided by 3, and over here I would put a positive 2, which is the solutions I have down here. All right. This was more of a proof than anything else to show you that the quadratic formula does work for problems that are factorable. Yes, well, I know factoring this problem is a lot easier to solve for x, but this was just a proof for you guys. Am I going to give you something like this on the exam? Yeah, I might give you one, to help you out a little bit, but I'm going to give you, problems that are not going to be nice numbers like radical 49. You might have like radical 51, and you're going to get stuck there. All right, so right now, I want you guys to do B. This one's going to be a little bit tougher. I can tell you right now the radical is not going to simplify nicely. It's not going to be a perfect square. So right now, I want you to pause this and go and work on it. All right, so you guys should have attempted the problem. So when you do this problem, you want to first get everything on the same side, okay? If you're solving for x, always set it equal to 0. I don't care what type of problem it is, always set it equal to 0. So that means we have to subtract 5 here. So our new equation is x squared plus 6x minus 5 equals 0. Let's identify our a, b, and c. This is my a, this is my b, this is my c. Let's put this into the quadratic formula. You can even try to factor this guy right now. This is unfactorable. There's no two numbers that multiply to negative 5 that adds up to positive 6. Does not exist. So if it's not factorable, we're going to use brute force and use a quadratic formula here, okay? So let's go ahead and plug everything in. So we have negative 6 plus or minus square roots of 6 squared. And when you guys do this out, you can just kind of multiply it in your head. 6 squared, 36. I already know that. Minus 4 times 1. You really don't have to write the 1 at all. Times negative 5, okay? Everything divided by 2 times 1. You don't even need to write the 1, okay? All right, big mistake I see a lot of students make. You guys get very, very cancel happy here. I've seen students do this. They do that right away, and they turn this into negative 3. You will get this wrong if you do that. Please do not do that, okay? There's actually a parentheses up here that lets you not cancel that stuff out. And plus, you have a plus or minus here, okay? You can't do that. So if you did that or thought of doing that, you should write a little note somewhere that you can't do that, okay? So like I said earlier, the main thing is the stuff inside the radical, okay? You need to simplify this guy. And although it looks easy, trust me, people get this wrong a lot. One simple mistake of subtracting first will kill you. Alright, so we have -6 plus or minus. And you're going to see I'm going to rewrite the stuff outside. I really don't care about that stuff right now. All I care about is the radical. 36 minus, 36 plus 20. Okay. 36 plus 20. And where are we at right now? Okay. Yeah, that looks good so far. Okay, let's go ahead and add up stuff inside the radical. 36 plus 20, this is 56, radical 56. And we need to break up this radical 56. So we need to find the biggest perfect square number that goes into radical 56. Okay, so we're going to do a little bit of guess and check here with our perfect square numbers. So it's 4 times 14, okay? So we could break up the radical 56 as the square root of 4 times square root of 14. I know it's kind of an awkward number, everything divided by 2. You always want to break it up with a perfect square number. You don't want to break it up with a number that is not a perfect square number, okay? So some of you guys are probably thinking 7 and 8. 7 and 8 is not a perfect square, okay? Although you could break down 8 into a perfect square, you could do that. But we just want the rawest perfect square number. The biggest perfect square number that goes into 56 right now is 4. All right, let's continue on a little bit. So, and remember, I'm looking for this right here, okay? The first thing I look for is that. All right, the square root of 4 is 2. And that square root of 14 code goes along for the ride. All right, this is a little tricky here, okay? We still have that parentheses right here. We still got that. That doesn't go anywhere, okay? I know a lot of you guys are looking at these 2's and itching to cancel this out. You can't do that. You're going to get this partially wrong if you do that, okay? It's going to kill you as well. Okay, what you can do is you can undistribute a 2 right here. Or you can see that they're all divisible by 2. You can do that as well. You can say I can divide 2 to that -6. I can divide that 2 into the radical 14. That's okay. That's legal. So we're going to actually do that right now. We're going to divide each of them by 2. So -6 divided by 2, that's -3. -6 divided by 2 is -3, and then we have the plus or minus still, that doesn't go anywhere. And when we have 2 radical 14 divided by 2, that's when you can cancel it out, okay? And that becomes radical 14. So let me show a little bit of work here. Sorry about that. Kind of jumped ahead. So we can do it like this. So -6 divided by 2, the plus or minus here, and the 2 radical 14 divided by 2, and you can see here, now you can cancel this guy out, and now you can reduce this guy. So then we get -3 plus or minus radical 14. Yes, you will have a problem like this, okay? It does get a little bit harder. The first quadratic equation that we did in example 2a was an easier one, so warm up, okay? B is what you're going to probably get on an exam. Are you going to have negative numbers inside the radical? Yeah, you are, okay? We're going to have negative numbers inside that radical, which brings us to our next example, complex solutions. Whenever you see the word complex, that means that it involves an I, and I means you have a negative radical, or negative inside the radical, okay? So we're going to start this problem. So just be prepared for an I involved or a negative inside the radical. Don't be afraid. All right. First things first, you want to move everything towards the positive x squared. Right now my x squared is positive. Move everything to the left side. Please don't be lazy and subtract that x squared. It makes life a lot harder where your a is a -1. You really don't want to deal with it when your a is a negative, okay? So move everything to the left hand side. Everything wants to gravitate towards the positive x squared, okay? So that means you subtract 2x and you add 5, please. Subtract 2x and you add 5. So remember, we are setting it equal to 0. We always set it equal to 0. And I'm going to write it right here, actually. So this is going to be x squared minus 2x plus 5 equals 0. Let's go ahead and identify our a, b, and c. A, b, c. All right. Okay, and let's go ahead and put in our quadratic formula. Please memorize that. So b is negative, so it says negative, negative. I'm just going to go ahead and start doing this a lot faster. So negative 2 is positive 2, plus or minus square root of 2 squared, which is a 4, minus 4 times, I don't really want to write that 1, so 1 times 5 afterwards. Okay, just save yourself here. And then 2 times 1 is 2. Once again, do not cancel out the 2's. If you have that itch to cancel out the 2's, it might be helpful to write this parentheses up top. You cannot do that. If you do that, you get it wrong. Like if you just stop right there, I don't look at the rest of the problem anymore. Okay, that's how I grade it. So please don't do that. If you find this problem really quick, like you solved it really quickly, you did it wrong. Most likely you did it wrong. All right, let's continue here. So we have 2 plus or minus. Remember, the stuff inside the radical is the most important. And I'm going to put the parentheses up top again for your guys' sake to know that to not cancel out anything right now. So we have 4 minus 20. Okay, we're going to go again. So 4 minus 20 is negative 16. Once again, putting the parentheses up top. Cannot cancel out. Right? And then we want to break down radical negative 16. So 2 plus or minus. Let's go ahead and take out an I right away. Right? Because that negative radical square root of 16. Some of you guys probably would have wrote just 4i. But I'm not skipping any steps right now. Still, I don't cancel out. Okay? You gotta refrain from that right now. Okay? I know a lot of you guys really want to do that. Okay, and then we go ahead and we break down the square root of 16. So this is going to be 4i. Yes, you want to put the 4 in front of the I. You don't ever want to go I4. Alright, and then the same thing, you can go ahead and divide here and divide here. 2 divided by 2 plus or minus 4i divided by 2. Let's make that look a little better with an I. Okay. Alright, so this is 1 plus or minus 2i. Okay, that is our solution. This also means that it doesn't touch the x axis at all. Okay. Alright, now I want you guys to pause and do example 3b, and then we'll come together again. Alright, let's see how you guys did. We got to go ahead and move everything towards that 2x squared, right? Because it's positive. Everything wants to gravitate towards that side. If that 2x squared was negative, then yeah, move it to the right side. Okay. So add 6x, add 7. I'm going to go a little bit faster here. Okay, so we have 2x squared plus 6x plus 7 equals 0. Let's identify our A, B, and C. A, B, C. Alright, negative 6 plus or minus square root of 36, 6 squared, right? Minus 4 times 2 times 7. Everything divided by 2 times 2, which is 4. Okay, don't cancel anything out. None to the very end. None until you simplify the radical. Okay, negative 6 plus or minus square root of 36 minus, so this is going to be 4 times 2, negative 4 times 2, negative 8 times 7, so negative 56 divided by 4, still parentheses, do not cancel out, equals negative 6 plus or minus square root of negative 20 divided by 4. Alright, you have to break down square root of negative 20. Don't be afraid of this negative inside the radical, okay? Parentheses still. Take out the I right away. And I'm going to break up square root of, oh, actually I'm not going to skip any steps right now. I'll show you guys what's going through the thinking process of breaking down radical 20. Okay, breaking down radical 20. We have to find the biggest perfect square number that goes into 20. And that's 4 times 5. So radical 4 times radical 5. Still, we don't cancel anything out. Okay, and then this is negative 6 plus or minus 2i radical 5. In this order, okay, it goes number, I, and then radical, always. Alright, same deal. We can go ahead and divide this guy and divide this guy. Negative 6 divided by 4, we're going to reduce that number. And then 2i radical 5 over 4. Alright, so let's reduce some stuff here. So negative 6 divided by 4, that's going to be negative 3. We have plus or minus. And then this is just going to be, the 2 cancels out, and it's, sorry, negative 3 divided by 2. My mistake. And then this and this cancel out, just becomes 1/2, so radical, so I radical 5 over 2. Okay. This could be an answer. Some people like to put everything under 2 since they have the same denominator. This is also acceptable. Okay. Hopefully you guys got this right. If you got to here, you didn't complete it all. Yeah, you have to go ahead and reduce it. So it's not completely reduced. You did do the majority of the problem right, like 90% of it. So make sure you guys get to the box answers here. All right, we're on our last example right now, and this is a word problem to see if a certain ball reaches a certain height, and we're going to use the discriminant part. Okay, I'm going to show you how and why the discriminant part is necessary in this one. You don't exactly have to use it, but it does help. So it says a ball travels at a velocity of 34 feet per second, and its path is given by, it says h, which is height, equals negative 16t squared plus 34t. T is time. Will the ball ever reach 15 feet? H is height of the ball, t is time in seconds. So we set this up. We're taking this 15 feet and we are putting it in for the height right now. So 15 feet equals negative 16t squared plus 34t. Let's make that look more like a plus sign. Okay. Alright, so there's two ways to do this. You can use a discriminant, or you can kind of graph it and see if it actually reaches 15 feet. So what it's kind of asking here is if you were to graph this guy, will it reach 15 feet? So let's just say this is our y equals, right? We can call this guy, we'll put up top here, we can say that this guy's the y1, this guy's a y2, right? That whole equation. We want to see if, and I'm just drawing something, I'm sketching here, if this parabola goes like that, if it reaches over, or if it's going to be under. That's what we're trying to see right now. So you could technically put this both into your y equals, y1 and y2, and see. Okay, but mathematically, we're going to use a discriminant here, and I'll show you what it looks like on the graph in a second here. So we're going to go ahead and use the discriminant part, but we have to first set it equal to 0. So when we set this equal to 0, we're going to subtract 15 on both sides. So this is 0 equals negative 16t squared plus 34t minus 15. Alright, so now that we have the equation like this, basically we're just going to see if it's going to be above the x-axis, or if it's going to not just be above it, but if it's going to have one answer or two answers. So basically, if our graph, after we graph this equation right here, if it goes over here, we know that it has two answers, right? So basically, if our discriminant is positive, if it's positive, then we know it will reach its height because it has two x-intercepts, right? If it has just one, right, that means that the parabola reaches right here. That means it still reached its height. So if it touches the x-axis, it reaches its height, but it doesn't pass it. If your discriminant is 0, it's below. Okay, because we subtract the 15 on the other side, all we're talking about is if it reaches the x-axis above it, on it, or below it. Okay, so we can erase this part right now. I was just trying to give you a visual here. So we're going to use our discriminant right now. So identify our A, B, and C. A, B, C. And if it's positive, it's going to reach its height for sure. If it's 0, it's going to reach it but doesn't pass it. If it's less than 0, then it's definitely not going to reach it. It's below height. So our discriminant, so b squared minus 4ac, and let's go ahead and see. 34 squared minus 4 times negative 16 times negative 15. Definitely use a calculator for this stuff. Remember orders of operations, okay? You subtract anywhere in the beginning of this, you're going to get this wrong. 34 squared is 1,150. And then negative 4 times negative 16 times negative 15 is negative 960. Okay. We go ahead and we add those up, and it's 196. 196 is greater than 0. So that means that on the x-axis, we're going to have two real solutions. It's going to look something like that. And this x-axis is kind of like the 15 at the moment, okay, 15 feet. So if it has two answers, like two real solutions like that, that means yes, it will reach 15 feet, okay, yes, it will reach, all right. And we can kind of graph this out a little bit too, so I'll show you guys. So if you want to go to your y equals right now, I've already put this into my calculator. You go into y1, you put 15, y2, you put in this equation. I changed the windows up a little bit because I want to see the y, right? So just to show you what the windows look like. Okay, I went it to 20, a little bit higher than what it is normal for my y max, increments of 1. I'll give you guys a minute here to write this down, or you can pause and rewind. And then we're gonna hit the graph button, and you can see here this is the path of the ball, and it reaches up to 15 feet. We can find the maximum height if we wanted to. Like I said, there's another way to do this. You can just find the vertex of this negative 16t squared plus 34t and see if it reaches. Okay, so what we did with this discriminant is we subtracted the 15 on the other side. So I'm going to clear this guy, and I'm going to show you we subtracted the 15 on this side, and basically this kind of shifts things. It shifts the parabola down, right? 15 units. Yeah, it pretty much just shifts the parabola down 15 units now, and we want to see if it's going to be above the x-axis. And you can see it is definitely above the x-axis, and because our discriminant was positive, that means it has two solutions. Okay, it has two solutions just like this right here. Alright, that's pretty much it. If you need to re-watch this, go ahead and do that. Your homework assignment is this down below, both of these guys. Okay, if anything changes, I'll let you guys know. Yeah, but I think one page has just regular quadratic functions, and the other page has radical functions with eyes. So that's why it's on two separate pages. And that's pretty much it.